We're going to be talking about some more probability things. Mutually exclusive is the new words that you'll see today. And first we're just going to talk about if things are mutually exclusive or not, and then we're going to find some probabilities for it. So two events that cannot occur at the same time are mutually exclusive. So they cannot happen, so they are mutually exclusive. Okay? So let's look at a few examples. First of all, we're trying to figure out if these events are mutually exclusive or not. So first of all, a junior winning the election or a senior winning the president of a student body election. So whenever we talk about somebody winning the election, only one person can win. Can it be a junior and a senior at the same time? This cannot happen at the same time. So it is mutually exclusive. Okay. Number two, drawing an ace or a club from a standard deck of cards. So if you remember what we talked about with the cards, there are 4 aces, and as far as the aces go, there's a diamond, there's a heart, there's a club, and there's a spade. So there's one of each of these. You can get an ace and a club at the same time because there is an ace of clubs. So it can happen at the same time. So not mutually exclusive. If you want to abbreviate that as ME for mutually exclusive, that is okay. Number 3, getting a sum of 6 or 7 when 2 dice are rolled. So can you get a sum of 6 or 7? For example, if I have 2 dice and I get a 2 and a 4, that's a sum of 6. Well, 2 and 4 equals 6. It doesn't equal 7. 7 would be maybe 3 and 4 or 2 and 5. This cannot happen at the same time because it cannot happen. It is mutually exclusive. So some other examples I want to look at are related to looking at some dice. Notice it says that we're going to be looking at some sums. Okay? Alright, I printed this list of dice for us so that we can look at it. If you'd like to write it down or Google it and have that picture on your phone so that you can use it when the time comes, that would be okay. Some things you might be asked are, what's the probability of getting doubles when rolling 2 dice? Well, doubles would mean 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So right there, that's 6 out of 36. You might be asked some problems like, what's the probability of getting a sum of 3? Well, looking at this, the only way you can get 3 are these 2 right here. So that would be 2 out of 36. So you can do lots of things with this. This is when you roll 2 dice, and it's what you get when you roll the 2 dice. So the particular problem that we're looking at says that we want to list all of the ways that you can roll a dice. Well, that's all the ways. But then it says you want to get a sum of 6. Alright, so when I add them together, I want to get 6. So 5 and 1 is one way, and 1 and 5 would be another. 4 and 2, and 2 and 4, and then 3 and 3. So these ways right here are all the ways. I'm going to write those down. So 1 and 5, 5 and 1, 2 and 4, 4 and 2, 3 and 3. There's all the ways that you can get a sum of 6. Okay, when you look at a sum of 7, 6 and 1 will work. 5 and 2, 4 and 3, 3 and 4, 5 and 2 and 5, 1 and 6. Notice it's always on the diagonal for the sums. So let's write those down. Alright, so the probability that you would get a sum of 6 or 7, or would mean that you just add how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 of them. So this is 11 out of 36 because there's 36 total possibilities. Now, if the events are not mutually exclusive, that means that they can happen at the same time. You have to think about it a little bit differently. And here's a formula, and if the formula helps you, that is great. This one, it says take the probability of A, take the probability of B, and subtract the probability of A and B. The reason you have to do this is because when you add the two probabilities together, you're adding something twice. And I'll show you that when we look at this problem. So it says rolling a number greater than 2 or an even number. Okay, so I'm going to do it separately. Probability of a number greater than 2, and then probability of an even. Okay, we're rolling a die, so we're just rolling 1, not 2. So the probability of the number is greater than 2. Well, we're talking about 3, 4, 5, and 6. So there's 4 of them. Okay. Probability of even, we're talking about 2, 4, and 6. And there's 3 of them. Well, notice that in this case, I've added the 4 and the 6 twice. If I say, oh yeah, well there's 7 possibilities that make that happen, but I've added the 4 and the 6 twice. So this says that you say 4 plus 3, and then subtract the common ones, which is the 4 and the 6. So 4 plus 3 is 7, 7 minus 2 is 5, so it would be 5 out of 6. The other way to do it is just look at the possibilities and pick all of the different possibilities. Oh, there's 1, 2, 3, 4, 5 possibilities, and I don't have to count those because I've already counted them, so I do 5 out of 6. I would usually do it that way if I can write it out, just because I think it's easier. But if you would rather, it would be 4 plus 3 minus 2, because there's 2 in common, which is 5, so then 5 out of 6. Alright, number 2. Suppose you draw a card from a standard deck. Probability of drawing an ace or a club. So we would try to figure out how many aces we have, we would try to figure out how many clubs we have, and then we would find the common amount, and that's what this says here. So there are 4 aces, and this is supposed to say an ace, so 4 aces. Clubs, there's 13 of them. There's one that is an ace of clubs that I have included already, so I add these together and subtract that common one. So that's 17 minus 1, which is 16. There's 52 total cards, so I divide by 52. And then also there's the complement, and we've kind of already talked about it, but I will just remind you about it. The complement is the events not happening, not A. So probability of not drawing a club, well, if there's 4 clubs, you subtract 52 minus 4 to get 48. So that would be 48 over 52. Not rolling a 6, well, there's 6 things. One of them is a 6, so you get 5 out of 6. So you just subtract there. Now, if you feel like you still need some help on that mutually exclusive, I do have some more examples to go through with you that I hope will help you a little bit more. The question is asking you first figure out if it's mutually exclusive or not, and then find the probability. So we'll look at some of those. So number 1 says drawing a card from a standard deck and choosing a king or an ace. So use what we've written about cards and try to figure this out. So first of all, can you get a king and an ace at the same time? Well, no. If I choose a card, it's either a king or an ace. It's not both. Because it cannot happen at the same time, that means it is mutually exclusive. When it's mutually exclusive, the probability is really easy. You just add the two probabilities together. So the probability of a king is 4 out of 52. The probability of ace is 4 out of 52. So you just add that together and get 8 out of 52. Rolling a pair of dice and doubles or a sum of 6. Alright, let's look back at these dice again. It says doubles or a sum of 6. So doubles we know are these right here. 6's are right here that we can add them and get 6. There's one that's in common, so that means it can happen together. So it is mutually exclusive. So the way that I figure this out, because it can happen, so it's not mutually exclusive, I'm sorry. Because it's not mutually exclusive, this is where you have to subtract off the common one. So the probability of getting doubles, there's 1, 2, 3, 4, 5, 6 of them. So doubles is 6. Sum of 6, there's 1, 2, 3, 4, 5 of them. But then there's one that's in common because of that 3, 3. So you subtract it off. And you get 6 plus 5 is 11. 11 minus 1 is 10. So 10 over 36 because there's 36 possibilities. If you didn't want to do it that way, you could just count. There's those 6 possibilities. There's 7, 8. We've already counted that one. Don't count it again. 9, 10. So you could just count the possibilities if you wanted to. Number 3. Drawing a 2 or a heart from a standard deck of cards. So can you get a 2 and a heart at the same time? Yes, you can, because there are 2 hearts. So you can. That means it's not mutually exclusive, so we kind of have to do it how we did here. How many 2's do we have? Well, there's 4 of them. How many hearts do we have? There's 13 of them. So how many are in common? The 2 of hearts. There's 1 of them, so you got to subtract it off to get rid of it. So there are 16 out of 52 that work here. There's 52 total cards, so add that and subtract 1. Okay, number 4, rolling a pair of dice and a sum of 8 or 12. So we're still looking at this again. So sum of 8 or 12. Can you get a sum of 8 and a sum of 12 at the same time? No, you cannot. So cannot means it is mutually exclusive. This one's a little bit easier because when it is mutually exclusive, you just add. You do not subtract like you did on the other 2. And so sum of 8, well, let's see here. 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. That's 1, 2, 3, 4. There's 5 of them. Sum of 12, there's only 1. Alright, so I'm going to write those out just in case anybody needs them. 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. That's the 8 ones. And then 12 would be 6, 6. So there's 1, 2, 3, 4, 5, 6 possibilities. So it's 6 out of 36 because there's 36 ways to have doubles.